VPN Fundamentals, Learning Objective and Key Concepts. Learning Objective. Describe the fundamental functions of virtual private networks, or VPNs, common VPN technologies, and the elements of VPN implementation and management. Some of the key concepts are virtual private network essentials, VPN models and architecture necessary for implementation, VPN transport and tunnel modes, VPN connection, encryption, and VPN authentication and authorization. What is a virtual private network? It's a mechanism to establish a secure remote access connection across an intermediary network, often the internet. Allows remote access, remote control, and highly secured communications within a private network. Employs encryption and authentication to provide confidentiality, integrity, and privacy protection for network communications. Trusted VPN. The primary organization owns all of the network infrastructure components. A dedicated set of channels is used across leased telco connections, provides physical isolation even on third-party equipment, hence the privacy is maintained. Encryption ensures privacy even over public networks such as the internet, and a hybrid VPN establishes a secure VPN over trusted VPN connections. In this diagram, we can see an example of a hybrid VPN consisting of a secure VPN across an intermediary trusted VPN. Remote access is different from remote control. A remote access link enables access to network resources using a wide area network, or WAN as we refer to it, link to connect to a distant network. Creates a local network link for a system not physically near the network. The client system can technically perform all of the same tasks that are locally connected to the client, and network administrators can impose restrictions on which resources and services a remote access VPN client can use. Consider a LAN, local area network, and a remote client that each have a connection to the internet. Connections are independent of each other. The LAN's connection is usually a permanent or dedicated connection supporting both inbound and outbound activities with the internet. The remote client can have a dedicated or non-dedicated connection to the internet. A new network connection is established from the remote client to the LAN across the intermediary network. This new network connection is the VPN. Here's an example of a corporate local area network and a remote client with internet access. Both can talk to the internet independently. They don't know about each other. But eventually, the remote client will want to talk back to the corporate network. A VPN is established between the remote client and a local area network over the internet. The remote client either has a thick client that would have the configuration and connect back to the corporate network, or you'd have a web browser URL that would connect back through SSL TLS encryption back to the corporate network. And it would establish a tunnel across the internet, much like taking a letter. You write a letter, you put it inside an envelope, that's the encapsulation, and that envelope goes across the internet or the mail network, public mail network, snail mail, and then it gets delivered to the recipient, which takes the envelope, opens it, which is de-encryption, takes the letter out to read it. And along that path across the public, you can't see into the envelope unless you open it. But that's the privacy. That's what the VPN is, that envelope that goes across. That's the encapsulation or the tunneling of the traffic from the endpoint to the corporate network. Secure VPN concerns. All VPN traffic must be authenticated and encrypted. A VPN without authentication is not private, and a VPN without encryption is not secure. All VPN endpoints must abide by the same security parameters and algorithms. Each VPN tunnel must have corresponding encryption key sets to securely exchange encrypted content. The same security policy should govern all endpoints. Proper encryption protocols must ensure that no external third party can affect the security of the VPN. Weak encryption makes the secure VPN vulnerable to attacks. Trusted VPN concerns. Based on the provider's ability to limit and control access to the VPN's content, only the trusted VPN provider should be able to modify the channels or pathway of the VPN. Only the trusted VPN provider can add, remove, or change data in the trusted channel. Addressing and routing performed within the trusted VPN must be defined before the VPN goes online. Services are usually predefined in the SLA or the service level agreement. Tunneling protocols encase the original network protocol so that it can traverse the intermediate network. Dormant forms of secure VPNs use IPsec or SSL/TLS as the tunneling encapsulation protocol. Protocols that create VPNs. So these are IPsec, which is Internet Protocol Security, PPTP, which is point-to-point tunneling protocol, L2TP, which is Layer 2 tunneling protocol, SSH, Secure Shell, SSL, Secure Socket Layer, or TLS, Transport Layer Security. What are the benefits of deploying a VPN? Could be productivity, granting workers the ability to access and use resources in a timely and efficient manner, assist in the completion of work. Remote access from a wide variety of devices. Workers may connect to the company LAN from laptops, tablets, and mobile phones through internet cafes, other hotel networks, and at other random Wi-Fi hotspots. They reduce the risk caused by insecure access locations, cost savings. Telecommuters and traveling workers save on long-distance charges. Businesses that need only internet links for VPN rather than dedicated leased lines between each location save on expenses. In this example, we see two corporate networks using different methods. One is using a dedicated lease line, which is on the left, so that they would have to lease telco lines from each building or corporate network location to each other to create the mesh network so that each one could talk to each other. That's very expensive this day and age. When we can leverage the internet, which is publicly available, and most businesses subscribe to an internet some way, somehow, then all you have to do is create a VPN firewall, put them at each location. They commonly connect to the internet, and you could build VPN tunnels to each location so that it appears one big network. That's very cost effective and very attractive in these days. Here's some of the benefits of deploying a VPN. Reduced equipment cost, unlimited geographic connectivity, increased flexibility and versatility of worker location, improved privacy and confidentiality due to strong encryption, verified transmission integrity, full scalable global infrastructure and architecture. Rapid deployment options, flexible integration with existing networks and technology, faster return on ORI than traditional WAN infrastructures, reduced dependence on long-distance carrier solutions, reduced support burden on internet service providers. What are some of the limitations of a VPN? Does not ensure quality of service. VPNs over the internet can suffer from latency, fragmentation, traffic congestion, and dropped packets. Fragmentation of packets is if strong encryption is not used, data may potentially be exposed while in transit over the internet. Vulnerabilities at VPN endpoints, difficulty in providing technical support remotely. What are effective VPN policies? Aspects of design and planning of a VPN policy include, but are not limited to, considering the benefits and drawbacks of software and hardware VPN solutions, imposing stringent multi-factor authentication, multiple elements that validate who you are on all VPN connections, implementing strong access control, which is authorization, restrictions on all VPN connections, defining how the VPN will be managed through which interface and by whom, exploring the complexity of patch management over a VPN, defining the mechanisms of providing remote technical support, VPN telecommuters, enabling detailed auditing in all activities occurring across or through the VPN, defining distinct qualifications or granting user access to telecommuting VPNs, prescribing the user training requirements for all VPN activities. Here's some of the VPN deployment models. You could deploy VPN solutions on edge routers, corporate firewalls, or a dedicated VPN appliance. VPN architectures. You can configure VPNs for just remote access. You can configure VPNs for site-to-site VPNs connecting to disparate locations, and host-to-host, one endpoint to another endpoint. In this example for remote access, also known as host-to-host, site VPN supports single-host VPN connections into the local area network. You can see the laptop and the desktop connect to the internet, different locations around the world, and they have an internet connection independent of the corporate network. They establish a VPN connection to the firewall. That's where they get their authentication and authorization, and then they get handed off to the local area network. Site-to-site VPN, also known as a LAN-to-LAN VPN or WAN VPN connections between LANs, supports secure connections between LANs over intermediary public networks, can be inexpensive mechanism to create a single distributed LAN. Site-to-site VPN with remote mobile users, a combination of site-to-site VPN concept with remote access VPNs. So here we have two corporate networks disparate from each other, and they can have a site-to-site VPN tunnel between the two firewalls, and the end users in each network would be able to traverse to each other's network through that tunnel, and they would appear as one big network instead of two independent networks. And VPN used to connect multiple LANs with remote mobile users. Same kind of concept that from the previous slide. We have two corporate networks, two disparate locations. We have remote users that need to talk to each side. They connect through the internet and get dropped off to the firewall, and they can traverse either network depending on which side they need to go to seamlessly. Host to host, also known as client to server, remote to office, or remote to home VPN, a direct VPN connection between one host and another, operates over a public network or within a private network. Over a public network provides a connection that is secure from the public. Over a private network provides additional level of security for mission critical or highly sensitive transactions. Extranet access positions a VPN tunnel endpoint at or inside the perimeter of an extranet. Serves as a pathway for business partners, distributors, suppliers, and others to gain access to corporate resources without exposing their traffic to the internet or granting users unnecessary access to the private LAN. VPN is linked into the extranet as opposed to the DMZ, provides greater security to the remote entities, grants the remote entity secure communications without significant risk at the VPN termination point. Tunnel versus transport mode. Tunnel mode encryption protects the entire original IP packet's header and payload. The encrypted packet becomes the payload of a new IP packet with a new IP header. Ensures the identities of the original endpoints of the communication are kept confidential. Commonly used by VPNs linking network sites together or providing secure remote access. Transport mode encryption protects only the original IP packet's payload. The encrypted payload retains the original IP header and protects only the payload and not the identities of the endpoints. The relationship between encryption and VPNs. Secure VPN traffic is encrypted. Some trusted VPNs may or may not use encryption. Cryptography, the art and science of changing information so that it's not easily recognized or understood by an unauthorized third party, includes encryption and decryption. Modern cryptography is based on algorithms. Encryption, the process of converting original usable data called plain text into unusable chaotic form called ciphertext. Decryption, the process of converting ciphertext back into plain text. A logarithm, a set of rules and procedures, usually mathematical in nature, that define how the encryption and decryption process operate. Encryption algorithms use a key. The encryption key is a unique and secret number that controls the encryption and decryption process performed by the algorithm. The bit length of the algorithm's key defines the algorithm's key space. Weak keys, shorter than 128 bits. Strong keys are 128 to 256 bits, and very strong keys are longer than 256 bits. So usually 1024 or 20 by 48. Symmetric cryptography, based on the algorithms that use a single shared secret key. A synonym for symmetric is the same. The same key must encrypt and decrypt the data. This key must be shared with all communication partners in the same session. Very fast in comparison to asymmetric cryptography. Examples of symmetric cryptography is DES, triple DES, AES, CAST, RC4, 5, 6, 7, IDA, IDEA, twofish, and blowfish. In this example, we see the symmetric cryptography process. Bob, on the left, has some data that wants to share with Alice in a secure manner. The data is created, then it's encrypted with a key, and that's K1, key 1, and that key 1 has to be shared with Alice at some way, somehow. And then when Bob shares the data in step 4, she receives the secure data, but has to use that pre-shared key to unencrypt and view the data. Asymmetric cryptography, based on algorithms that use either key pairs or a special mathematical mechanism. Asymmetric cryptography that uses key pairs is also known as public key cryptography. A synonym for asymmetric is different. The key pair set consists of a private key and a public key. The private key is kept secure and private at all times. The public key is put out there in the open public access for use. It's very slow in comparison to symmetric cryptography, best suited for identity proofing and key exchange. In this example, Bob has a private key that he has generated and also a public key that he has generated and publishes the public key out on a server. Bob takes his data, generates it, encrypts it with his private key, sends it to Alice. Alice can get Bob's public key and take the data that she was sent and then decrypt that data. Digital signature proves the identity of the sender, is not encryption, does not provide confidentiality protection, and is improved through the addition of hashing. In this example, we see symmetric cryptography process of a digital signature. Alice has her private key and publishes her public key, so Bob can get her public key and decrypt the data that she sends to him. Asymmetric encryption process of a digital signature with hashing. It's similar to what the symmetric part is, but the hashing is what is unique. Each data gets a unique hash, and that hash is shared, and that hash is part of the decryption process. Hashing is a cryptographic function that takes the input of a file or message and creates a fixed length output. The input can be of any size, but the output is fixed length based on the hashing algorithm used. does not modify or alter the original data in any way, but rather uses the original data to generate a hash value as the new data item. Verifies integrity based on the complex mathematical functions used in the hashing algorithm. Is a one-way function. VPN employs hashing often as a part of digital signatures as a method to confirm that transmitted data has retained its integrity. The overall cryptographic process of establishing a VPN connection. The basic VPN setup process. Bob computes the hash from the message. Bob encodes the hash using his private key to create a digital signature. Bob generates a random symmetric key. Bob uses K1, the key, to encrypt the message. Bob obtains Alice's public key. Bob encodes the key with Alice's public key to create a digital envelope. Bob sends the digital signature, the encrypted message, and the digital envelope to Alice. Alice uses her private key to decode the digital envelope to reveal the key. Alice uses the key to decrypt the message. Alice computes the hash of the message. Alice obtains Bob's public key. Alice decodes the digital signature with Bob's public key to obtain Bob's hash value. Alice compares the pre and post hash values. If the hash values are the same, then the message has retained its integrity. Thus, the correct public key decoded the digital signature. Bob's identity is verified. Authenticity and non-repudiation have been verified. This exchange enables the symmetric key to secure subsequent messages from Bob to Alice or from Alice to Bob. Once a VPN has been established between Bob and Alice, an exchanged session key exists at both endpoints. Digital certificates. A public key and private key pair digitally signed by a trusted third party. The third party is a certificate authority. The CA first verifies the identity of the person or company, then crafts and issues the digital certificate. What is VPN authentication? Authentication, the process of confirming or providing the identity of a user. Highly important for VPNs because VPNs allow external entities to connect to and interact with private networks or systems. What is authorization? Authorization is controlling what users are allowed and not allowed to do, also known as access control. Clearly defined policies establish activities that will and will not be supported for VPN connections. The initial concern is defining the users allowed to establish a VPN connection. If VPN connectivity is neither essential nor conducive to a worker's assigned task and responsibilities, the workers should not be allowed to open the VPN connections. Access should also be restricted to resources across a VPN, even for authorized users. In summary, we've talked about virtual private network essentials, VPN models and architecture necessary for implementation, transport and tunnel modes, connection encryption, and authorization and authentication.